image is used as a trigger to bring this virtual content.
So it's both image processing and graphics.
Yes, graphics in the sense we need to have the 3D models built in advance. So I have some demos I'll show you. I'll put the virtual robot here and all of us can take a selfie. Okay, so we have got that virtual robot built by some 3D artist. So when we actually build applications, yes, we need a team of 3D artists. We need a game developer, a computer programmer, and a designer for making the app look good, the user experience and so on, all these UIs and so on. So it's a teamwork actually when we have to build a product. So far here, yes, it's image processing as well as graphics here. And there could be animations, so many other things that you can add. So this is the simplest approach using images. You can even trigger using your face. So when we have a face pointing to a phone pointing to us, we can put spectacles, we can put jewelry, we can put any kind of makeup, we can even try the costumes, watches, rings, anything on our body would be a trigger. So there are a lot of products nowadays in the market coming up with these try-ons, virtual try-ons, especially jewelry. I think Danish has it, Lenskart is using it. And even in Flipkart and Amazon, you can try furnitures, you can try before you buy, right? You can try whether it will fit in this slot. If you have to fix this on that side, will it fit within that, between the two space, right? All those things you can try before you actually bring it. Okay, so let me move on. So that was just the principle of augmented reality development, but you could as well use other objects to trigger the virtual content. So instead of images, so this is using images. Using the images, you know the orientation and position. You could also use plane surface detection. So again, all the depth sensing, you'll be able to find out those points. And if they lie on a plane, then you can say that it is a floor or a table surface like that. So normally we want to put supposing I want to put a flower vase, I want to put it exactly on the plane, right? I don't want to put it at some other place. So plane detection is very, very useful. If we are able to detect the plane precisely, then our job is simple. We just place a virtual object there. Face tracking, very precise face tracking is available nowadays. So you can put any augmentation here, any kind of face filters. You can do glasses to lipstick to cosmetics to anything that you can imagine. It could also be a 3D product. So instead of images or planes or our face, you could have a toy, say a Lego toy. And the toy, if you are able to recognize, you can put tracks, virtual tracks, fumes, and other effects. Dragons can come. So many things you can do when you are able to recognize a 3D model. So 3D model based AR is also there. In fact, the first one which I showed, where you have to recognize an equipment or an engine or whatever, right? And to be using that particular app for remote assistance, we need to recognize the 3D model. So that comes under this category. So there are different ways of triggering this augmented reality. Let me also talk a little bit about, just in one slide, about this mixed reality. This is actually a video shared by Microsoft. They have this head-mounted AR glass. So AR, it's mixed reality headset, so dedicated for observing these virtual holograms, but not on a screen. Rather, you just wear the headset and you see in front of you. And the good thing is that you can walk around, you can see from all sides, and also people wearing the same headset can see the same hologram. So when I wear a HoloLens, I'll be seeing some virtual hologram in front of me. But if you are not wearing it, you will not see what I am saying, right? So here, what they have done is they have shown this demo where there is shared experience. So anybody wearing this headset anywhere in the world can see this hologram right in front of them. So this is possible now with this shared experience co-location apps. You can collaborate with anybody in the world, and anybody can even this classroom, for example, someone can wear a Apple Vision Pro. Supposing I am broadcasting this thing live, then he or she can also be here virtually. So all this collaborative work environment is also one booming area, which I also want to touch upon towards the end of the session also. I'll talk about this again. But this is one of the state-of-the-art headset for MR. Unfortunately, it has been discontinued. Microsoft decided to discontinue it, but it was one of the state-of-the-art headset for mixed reality. Yeah, so now let me just show this video and we'll see why this 3D or this interactive virtual content is very, very powerful for marketing. Follow this behind. But anyway, so this kind of 3D billboards are installed in busy intersections like the railway station, the bus stands, and so on. So people are hooked to this kind of ads, and with this 3D billboards, many of these products, they can showcase their products and capture the attention of the passerby, and also it helps in marketing, brand recall, and so on. Let me go to the next slide. Yeah. So now we have seen what is AR, what is VR, and with the advancement of AI, we also have a lot of add-ons in this technology. We are now able to track our fingers very, very precisely. So before, in my time, I was doing just hand tracking. We were not able to track the fine finger gestures. It was very, very difficult. But now it's so precise. So even the fine finger tracking is also very, very precise. So we are able to write, we are able to type in the virtual environment. And also Facebook and so many other companies, they are doing with some kind of a wristband. So this wristband will have the muscular signal, the EMG sensor, and it will be doing this multi-dimensional signal processing, and using this, it can capture your finger gestures. So again, if we do this, if we wear this wristband, then we don't need these controllers. So controllers help us in right now interacting in the virtual environment, but this can be done away with using this hand tracking or some kind of EMG signal, biomedical signal processing. In fact, the Apple Vision Pro, if you have seen, does not have any controllers. It can track your hand, it can track your eye gaze, the direction in which you're looking at, and also it can understand your voice. So you can talk to the device and it will perform the intent detection. So this is the representation of the eye gaze direction. Here you can just talk to the environment and say, okay, I changed the color of this walls to some pink, for example. So you can just talk to the virtual environment and it will respond if your headset knows your voice. This is some research work which people are doing with the help of brain signals. You are just controlling devices. Normally, this we don't see much in the consumer side, but for research, people are doing it. But all of these are already available in the advanced headsets nowadays. So they come with voice recognition, they come with eye gaze estimation, at the same time your hand tracking, fine finger tracking. And the other thing is that, as I said before, these devices are becoming more and more powerful. There are a lot of sensors here which can understand each and everything around us. So the Microsoft has this HoloLens which can scan the entire room and it knows the depth. So this all the objects are understood, and then you can now make a virtual character sit on the couch. You can put some screen on the wall or anywhere because you know the geometry. So the headset allows you to have this kind of digital and physical things interacting seamlessly. So this is one very useful application which comes now, which is possible because of the advancement of AI. Basically, we are able to understand everything. We know that this is a chair, we know that it is 2 meters away from me, we know the height, everything the headset knows. So because of which there are a lot of interesting applications people are coming up with nowadays. There are a lot of cool apps there where you kick a physical ball. If you kick a physical football, you can have a virtual wall, you can break those virtual walls, and there's a lot of exercise and some kind of games being developed because of this particular capability. So now let me come to some of the application side. AI in games. So many people these days, especially the youth, they are playing a lot of games and spending a lot of time in gaming. But what I want to mention here is that it's not just gaming, but rather learning how to develop the games. So if you know how to develop these games by not just playing it, but you will be able to program all the enemy characters. Basically, they are called the non-playable characters. Whatever character you are playing is the player. The rest are non-playable characters, and these non-playable characters, NPCs, they are called in the gaming literature. NPCs are all AIs. So there is a lot of scope of implementing AI in gaming. Basically, behavior trees. So it is called behavior trees, which industries use in gaming, and also goal-oriented action planning. So these are the methodologies used in gaming. You decide the behavior of each and every of these characters. So if they are in the line of sight, they'll come and attack you. If they are 50 meters away, they ignore. If they get hurt, they will retreat. So all these behaviors you have to program, right? So you could have a lot of optimizing your inventory. Some will be going and collecting wood, or some will be doing some business. So all these things you have to organize it. And basically you are the creator, right? You are like God in this particular virtual world. And you must have heard about this AlphaGo and IBM Deep Blue, which have already defeated. They have surpassed human level intelligence in some specific games, right? So AI has advanced a lot, and there's a lot of use of AI in gaming as well. One thing which has become very popular since the COVID times is this virtual education, virtual conferencing, or virtual classroom. So we have, in fact, during COVID times, we have done a lot of simulations for a science lab, science experiments, PU experiments, because we could not go to the college. They asked us to create all the labs, physics, chemistry, and biology, and we simulate them. It has to be realistic. Students will just try that and understand. And the good thing is that it's not just understanding once, but you can try as many times as possible. So compared to the actual physical lab where you get only one chance, here you can practice it again and again, and it's very easy to scale up, right? If you have one app built, it can reach thousands, millions, and billions of users. So that is the advantage of this virtual simulations. So let me just play this video. So this is a physics simulation from.
What if you could learn physics from the comfort of your own home? Introducing ATAL Physics 1. ATAL Physics teaches you about all things physics and includes labs co-developed with actual teachers. They include 6 labs with everything from Newton's laws of motion to the theory of relativity. Imagine standing out in space, observing how the Coriolis effect creates cloud currents, or shrinking down to the size of an atom nucleus, looking at how the intranuclear forces affect the protons and neutrons. With ATAL Physics 1, you're not just learning about physics, you're experiencing it. Whether you're a student struggling with physics homework or an enthusiast looking to deepen your understanding, ATAL Physics 1 is something to do. Available now, ATAL Knowledge, virtual education, real understanding.
So this is one such app which they built for physics, simulating so many of the experiments in physics. And let me show this one also. This is for biology. So you can see different layers, different organ systems, and so on. And again, the dissection. So this is again another app which is available. So there are a lot of simulations like this which helps students to practice some of these things without, like the dissection, we don't need to kill an animal, but they can learn it here. And also some people have some kind of nervousness cutting some animals, so it could be a useful alternative. Here is one simulation where we use the augmented reality image cards. So we bring this image pattern, and once it is recognized, you can see the hydrogen atom, and you can have fun with all these cards, and students can combine them. They can build different molecules and understand their structure of the atom also. So these simulations can be done. So when they are apart, these individual atoms, when they come close, it becomes a molecule. So all these simulations, along with the atomic structure and the animations. I think the audio is not good, but anyway. So here it's an open exercise. There is no fixed pattern, right? How you have to combine the elements. So students can have fun with the AR cards. So if you provide them 24 AR cards, they can do a lot of trial and error, and they can figure out what happens when any of these things combine. So I hope you get the gist of what is happening here. Basically, we are augmenting this learning with the help of these virtual simulations. Here is one thing which I don't know if it works. So you have these digital twins nowadays, exact replica of a physical entity. So it could be a replica of this campus, or it could be a replica of any device. So let me just play this. Can I play this? Yeah, it's playing. So this is a simulation which I have built. Now basically I basic parameters of a waveform. So we have seen here a sine wave, and I can change the frequency here. So this simulation is done by choosing this frequency. If I change the amplitude, if I click here on amplitude, then it will affect the amplitude. Then this could be a different waveform. If I click here, the triangle waveform, square waveform, and so on. So all this can be simulated. You can increase the amplitude. You can, so let me go back to the sine. You can even go to the phase, so you can change the phase. So changing the phase of the waveform and so on. So all this can be simulated. So basically, in effect, what we can do is that we can virtualize the entire lab. All the equipments can be virtualized in a similar way. We have to program each and every buttons. So to do this, I don't know how many buttons are there and how many functionalities are there. It might be 50, 60, 100. That we have to simulate. And once that is done, this should be functioning as a digital signal function generator. Let me go back. Yeah, so talking about digital twins, it could be as big as this entire campus. So you only need to scan the campus in 3D. So if you have a 3D model of your campus, multi-story building or whatever, or the entire building can be virtualized. Now once we have this virtual campus with your virtual 3D model, you can build those labs. You can do whatever you want in each of these chambers. So this is again possible with the help of high-end scanners, 3D scanners. You can build 3D environments like this. Not just digital twin, but rather it is also useful for real estate. So people are showing this kind of 3D visits for rentals. So many rental agencies would like to have this kind of walkthrough, virtual walkthrough. You can see this house without actually visiting it, right? So it's useful for real estate and renting kind of application also. By now, I think we are convinced that this AR and VR, mostly VR here, VR is quite useful for skilling, training, and so on, because the moment you wear this VR headset, you are inside the virtual environment. You are immersed in that environment, so you can be exposed to situations like this, dangerous, hazardous situations, and you can learn how to respond to these kind of situations. So fire safety training and a lot of industrial training required in VR is the ideal platform for VR training, welding, and so on. All this oil, petroleum industry, they use a lot of training in virtual reality. This is another simulation which I want to. So this is about commercial fishing. So this we did it for some fishery university in Maharashtra. So they have this commercial fishing nets which are called this stern trolling nets. It's as big as the 3 football grounds, like 300 meters wide and 3-story building tall. So it's massive nets which they drop it in the sea and they pull it with this boat, stern boat. Now, teaching these concepts in the class, it was quite difficult. So they want to have it simulated. So let me just show you the video, how it is actually, how the nets go under the bed of the sea. So there are different scenarios where this virtual reality or 3D immersive content can be used for teaching and for learning. So the nets are dropped, and on the seabed, it is being pulled, and there are a lot of, actually I don't know, we cannot see clearly, but there are some weights which rest on the seabed, and it is being pulled from the boat. And this is used for commercial fishing. And in fact, to create this kind of simulation, our own engineers, they've gone to Maharashtra, they've gone scuba diving, 100 meters inside the sea, and they've captured a video. And together with subject matter experts, this kind of content is created. So this getting this, we cannot just create it because we don't know the subject matter experts, right? So we need to collaborate with the actual teachers, their content, and then we virtualize it. I cannot see the net properly. Sorry. Okay, it's down below there, the green one. But its actual size is more than 300 meters wide. So it is a massive net. And teaching these things to students in the classroom, teachers find it difficult. And there are so many simulations which help in explaining these concepts. One of the highest adopter of virtual reality is this manufacturing and automobiles. Nowadays healthcare is picking up, but manufacturing and automobiles is one of the highest adopter of VR, where you can actually simulate everything, right from prototyping, testing, everything before production, everything can be done virtually. So this is one good platform, and the good thing is that you also have the collaborative shared environment where you can discuss. So during the prototyping stage, there's a lot of design stage, there's a lot of this shared collaborative work which is required, and VR provides that. Healthcare is one domain which is picking up recently. Now it is being used for so many applications. So this is more like an augmented reality, right? On the physical person, you have augmented its CT or MRI scan. So it is all overlaid. So this helps in precise pinpoint surgery. So the incision can be minimized. Knee surgery simulations in VR. This could be about the human anatomy of the heart. Dental crown preparation in 3D. So there are so many applications where you can learn how to prepare the dental crown. Well, this anatomy, these are all anatomy related. Some general, what is it? The CPR or first aid, any kind of procedures you can teach in this virtual simulations. Another subdomain is this VR rehabilitation. So rehabilitation is also widely used. VR is used because most of these patients, they are reluctant to do the exercise that is required because it's painful and it's difficult for them to do it. So normally what they do is that doctors want us to actually create a VR app. So when they wear the VR app, they'll be seeing some kind of game, some balls coming towards them, and they'll be catching them or avoiding the balls or whatever. So basically it's like a gamified therapy that the doctors want to give. So the doctors will assess based on the user's the range of motion, and then based on the requirement, doctors will suggest some specific treatment in the form of a game. So when you wear the VR headset, you are in a virtual environment and you are just playing a game, but in the process you get the necessary therapy. So this is one way of gamified therapy which is very much used in rehabilitation. Another application could be this sports or fitness training. I'll play this. So here you can see your body pose is detected, and let me just pause it here. If you pause it here, you can see all the joint angles, and so this is obtained with the help of a motion capture suit. So in my previous company where I work, we have a product called HoloSuit, and that HoloSuit, when you wear it, you get all these joints. So this is available in real time. So whatever stroke that you hit, you get all the join angles, and this is very useful for a coach. So for coaching, this data is very important, and this can help to